So we're just going to run through this little how these binary trees work so that you understand what these algorithms are doing. And there's actually a kind of a useful little graphic in the book. And we're going to kind of go through the logic here. And this is creating the binary tree. So here's our data. And so what it does is if there's no node for the first one, which there wouldn't be, it creates it. Okay, and then it looks at the next piece of data, which is a 5. So if the 5 is greater than the value, creates a new node on the right. If it's less than the value, it creates one on the left. So 5 is greater, so it's going to create a node over here on the right. Okay, and then it looks at the next value, which is -2. So starts back up here at the top. 1 is -2 less than a 1? Well, yes, it is. So it goes on to the left. Okay, and then our next value is a 1. So we're going to follow the node on the right. Okay, at this point, 5 is the end of the line. And is a 1 less than a 5 or greater than a 5? It's less than, so it goes on the left. Okay, so you can see it over here on the left. And then we get our next value, which is a 6. So the 6 is bigger than the 1. It is bigger than the 5. It's going to go on the right. Okay, and so this is what our little structure looks like. Now, to retrieve the data, here's the algorithm for that. But basically, what you do is you start at the leftmost tree. And if that is not empty, so the leftmost node, you retrieve that value. Okay, and then you go up from there. Okay, so we would retrieve the next value, which is a 1. And then that's kind of done. So then we go to the next node and the leftmost value, okay, which is a 1. Then we retrieve the 5, and then we kind of follow it down to the 6. Okay, so that is how the data is retrieved. Now I'm going to go through a little exercise in the book that's going to actually create a little tree class with a generic. So I'm going to pause here and move this to a different screen and start up Visual Studio. So I'm in the new project window here, and language is C#. And what I want is a class library. So it's down here. I'm going to select that. For the project name, we're going to key in binary tree. And I'm just going to put it with all of my repositories. So I'm not going to store it where the author is directing it. I'm just going to click on next. .NET 6 long support is correct. And I'm going to create. So you can see it has kind of created a little generic class for me. I'm going to rename that. And I'm going to call it tree.cs. And then I'm going to start modifying it. So public class tree is right, but this is going to be generic. So I need to put my little generic ID in here, which I'm going to say, I'm going to call my generic T item. Now we could call it T or, tree item or whatever you want. I'm going to kind of stick with what the book is using here. And this is going to implement the iComparable interface. Oops. And actually, the where should be here. Where T item is iComparable T item. Okay, that is what we want. So T item is going to implement the generic. So basically, our little tree T item is implementing incomparable, our iComparable T item. So this iComparable is a generic and we are implementing it. Okay, we are going to have 3 properties. 2 are nullable and the other one is not. So when you put in a question mark, that means it's nullable, which means it may or may not have data, which kind of makes sense, right? If you think of that node structure that we created, uh, and that was the topmost value, you may not always have a value on the left or the right. Okay, so those could be null. The next thing we need to create is a constructor. And so what we are going to do is we're going to put a value into node data, but we're going to set the left and the right to null. Okay, so here's my generic. And we're bringing in the value here. We're calling it node value. We're setting that to our topmost node, and then we're setting the left and the right side to null. And we need to be able to insert. So we are going to add an insert method. Okay, now this insert method is going to be somewhat complicated. So here is kind of the shell, but this is the algorithm that we need to follow. Okay, and this is going to determine if we put the value on the left or the right. So first we've got our current node, and then we have to compare that to the new one that's coming in. And that'll determine if we put it into a tree on the right or the left. Okay, so this ends up being the code to insert the value on the left or the right. So I'm going to pause while I get that code in here. So here is, oops, Here is that code that we were just looking at, where it is checking to see if it's greater than 0 to determine, if it needs to go into a left tree or a right tree. Now, this adds the values to our little tree. Now we need a method to retrieve the values from the tree. Okay, and remember we did see algorithm for that as well. Though it may take me a while to find it. All right, so here's our little algorithm for retrieving from the tree. And now we're going to implement that. So I'm going to pause a sec. All right, so this little walk tree method is going to the leftmost node, or basically checking to see if it's null or not, and it actually retrieves the value and appends it to a string, does the same thing on the right. And it's implementing that algorithm that we just looked at. Okay, so this is our new little class. We're going to run a build. Okay, hopefully you all see that it succeeded. And so now that we have our class, we can actually add it to a project. Okay, because you can see that this is not a program.cs file, does not have a main method, so this cannot run as is. So what we have to do is add a new project into this solution. So we need to right-click on the solution. Okay, and then we're going to go to Add, and we're going to choose a new project. Okay, and so this is going to be kind of similar to what we have been doing. We're going to choose console application, should be C#. And we are going to call this binary tree test. So we're going to test our little class. Okay, and so long-term support is fine. And let's see. So we want this to be the startup project. So we're going to right click on the binary tree test project. And we're going to select set as startup project. Okay, and what we also have to do in order for this to run is we have to add a project reference. So we are going to add a project reference. And we want to add or connect the binary tree to this because this is where our program CS file is. And we'll click OK. Okay, so that connects those two. So if you look under dependencies and you look under projects, it has connected the binary tree so that our program CS file can use it. Also, what we have to do up here is add a using statement and tell it that we are using binary tree. And then we are going to get rid of this and add the statements that will add integers to our tree. So I'm going to pause a second. All right, so what this is doing is it's creating an integer version of our binary tree. So here's the binary tree. The compiler is going to do an integer version of this tree. And we're creating it with 10 values. Okay, so it goes through the constructor, creates our tree, and then you can see that we're calling the insert method and we're adding values. And they're not sorted. They're just in a random order. So here we are calling this. Remember, t_item is now integer. And so it's adding a new item. Remember, this is now integer. Okay, and so it's checking the new item to see if it's greater than 0, and it's determining basically where to put the item. Does it put it on the left or does it put it on the right? Okay, and then how far down does it have to go? Because if you remember, the way that that looks graphically, I'm going to pull it back over here so you can see it, this is basically what it's doing. Okay, it's adding to the tree and it's figuring out, you know, where the null values are, what the current node is, and figuring out if it needs to add a new one on the left or the right. Okay, so that's kind of what's going on in here. Then if we go back over here, I'm going to save this. So we get everything inserted. And then we take our tree object and we call walkTree, which retrieves the values. Okay, that is basically what the walkTree does. It goes down the various sides of the tree and it will retrieve the values. And they will end up being in sorted order. Okay, so it checks the left side to see if it is null or not. Okay, and then it checks the right side to see if it is null or not. Okay, so it's calling that. And then we're storing that data in a string called sorted data, and then we are going to print that out. So if we run this, we should see that data come out in sorted order. Now this also works for, so we had integers, but we could actually send it any data type, right? So let's add more to the bottom here. So we're going to now send it some string data, and it will also sort the string data. So I'm going to pause here. So now that I've added the string version, the compiler is going to compile a string version of this class. Okay, and so it's going to insert the values. And remember, we are implementing iComparable. So iComparable is kind of handling, determining, if the value is, less than or greater than. So we don't really have to worry about that logic. So as far as the text goes, iComparable is handling that. So what it's going to do is it's going to return a value less than 0. if the current instance is less than the value it's comparing to, 0 if they're the same, or greater than 0 if the instance is larger. So iComparable is handling that. It handles it with numbers too, but it's nice that it's handling it with text because that would be a little bit more difficult for us to do. So iComparable is determining if it's greater than or less than. We're adding it to the tree, and then we are retrieving the values from the tree, and they will be in sorted order, and we are printing that out. Okay, so although this does not make a whole lot of sense, it is in sorted order. Okay, so that is the template version of sorting. So this is how we are using generics to implement iComparable.